Assalamu alaikum sir, welcome to my presentation. Welcome to my information system security presentation. My name is Lami Akhtar Rumi. My ID is on 83353896 section C and presented to MD Maruf Hassan sir, assistant professor in the Department of Software Engineering at Daffodil International University. So my presentation topic is hashing in birthday paradox. So first of all we need to know what is birthday attack. A birthday attack is a type of cryptographic attack that exploits the mathematics behind the birthday problem in probability theory. This attack can be used to abuse communication between two or more parties. The attack depends on higher likelihood of collisions found between random atoms and a fixed degree of permutations. Understanding the problem, we can take some of example. Like as an example, consider the scenario in which a teacher with a class of 30 students, here in n could be 30, asks for everybody's birthday. For simplicity, ignore leap year to determine whether any two of have the same birthday corresponding to a hash collision as is described further. So we can here we are ignoring the leap years, and the next verse, intuitively, this chance may seem small. Counterintuitively, the probability that at least one student has the same birthday as any other student is around 70% for n equal to 30 for the formula. So here is the formula: 365 by 365 by 9 some into 365 to the power n. If the teacher had picked a specific day, say 16 September, like here we taking 16 September, then the chance that at least one student was born on that specific day is 1 minus 365 by 365 into to the power 30, about 7.9% only. In a birthday attack, the attacker prepares many different variants begin and malicious contracts, each having a digital signature. In this fictional example, suppose that the digital signature of a string is the first byte of SHA-256 hash. So we are taking the pair found indicated in green. Note that finding a pair of benign contacts blue or pair of malicious contacts red is useless. Attackers the victim accept the benign contacts. The attacker substitutes it with malicious and claims that victim signed it, as proven by the digital signature. The birthday paradox observed that is a room of like a room of 23 people. Here is the another example of I am describing you. The odds that at least two people share a birthday is 50%. In other words, if you have the uniform hashing function that outputs a value between 1 to 365 for any output. Another useful calculation is the expected number of collision for sequence of n values when the range of the hash function contains d hashes. The closed form solution is n minus d plus d minus 1 by d to the power n. So here let d be the number of days in the year. For real birthday, d would be 365, but for hashing, d is the size of range of hash functions. Here you can see d minus 1 by d to the power k minus 1. In a room with k minus 1 people, the probability the next kth person will not have the matching birthday to someone already in room is on this d minus 1 by d into to the power k minus 1. Hence, the probability that kth person will have a match is 1 minus d minus 1 to the power by d to the power k minus 1. To compute the expected number of matches in a room of people, we have to calculate the additional matches added by the first person plus the additional matches added by the second person plus the additional matches added by the third person plus additional matches by the kth person plus the additional matches by the nth person plus. Since each additional person will either match or not match, the expected number of additional matches added by the kth person is 1 minus into d minus 1 by d k minus 1. So the number of expected matches for n people is summation of k to the power n k equal to n 1 minus 1 d minus 1 by d to the power k minus 1, which sign is n minus 1 summation of k equal to 1 into d minus 1 by d to the power k minus 1 using the closed form solution for a geometric series. We can compute a closed form for the right hand side, like here is the right hand side calculate we have just declared, and the to the power k equal to 1, and the next was k is equal to 0, and then we take the calculation and get the our last and final output, final digit, final rules, and which is d minus 1 by d into n. So substitution back into the original formula is n minus d plus d minus 1 by d to the power n for the number of expected matches in a room of n people. So it is the expected matches of room of n people. So thank you, sir. Thank you for listening. I hope you have understand what I am trying to say about hashing problem further. So far, I hope I believe that you have understand what my thoughts and my topic. Thank you. Assalamu alaikum.